Okie dokie. In this problem, I will work out examples 2, 3, and 4 much faster than I did in the other video. If you want to see a more, bigger breakdown and whatnot of this problem, a more in-depth explanation, please visit that problem. I'm going to run through these much faster. All right. 1% of the population has the disease. That means 0.01 goes here, which means the remaining 99% do not have the disease. So 0.99 goes here. They say the test indicates the presence 89% of the time when it's actually there. So we have 0.89 going here, which means the remaining 11% goes here because 0.89 plus 0.11 adds up to 1, or 100%. The test indicates the presence 0.03% of the time when it's not present. So of the people that actually do not have the disease, 0.003 or 0.3% of them will test positively. And then that means that 99.7% of them will test truly negative, okay? So after filling in all this, they ask, what percentage will just test positive? So we want to follow the positive paths here. So we're going to multiply 0.01 by 0.89 and add that to 0.99 times 0.003. Let's break out Siri or any calculator you have. What is 0.01 times 0.89 plus 0.99 times 0.003?
It's 0.01187.
Beautiful. And as a percentage, moving the decimal 2 over, that's 1.7%. 1.187% is option D, and we're done. Let's do 2 more. You know the deal, 1% has the disease, so that's 0.01 again, which means this is 0.99, the remaining, percentage of people. 93% of the time it's going to test truly positive, which means 7% or 0.07 people that have the disease will test negatively. And then it indicates the presence 0.2% of the time, so 0.002 will test positively even if they don't have the disease, which means that 99.8% will test truly negative. What percentage of the total population will receive a false negative? So we have to think about which one of these is a false negative. I went ahead and labeled them in the very first video. So the false negative lies in the second, spot here. So in the second spot, this is the false negative because it's it's the category that have the disease, but they're going to test negatively, and so that's a false negative. So we just want to follow this path here. So all we do is 0.01 times 0.07. And I think that's just going to bring the decimal way down here. So it's just going to be 0.0007. I think that's right. Let's see what we have. Definitely something with a 7. And I think that is right once you move it. Yeah. So this is this decimal, which is equivalent to 0.07%. Which is option D. Break out the eraser to see that D is our answer. Let's do one more. All right. 2% have the disease, so 0.02, which means that 98 do not have the disease. 85% will test truly positive, which means that 15% will test falsely negative. And then 0.2% of the time, it's going to show the disease is present even when it is not, which means that 99.8% of the time, you'll have people testing truly truly negative. They ask what percentage will test negative. So we follow the negative routes here, multiply 0.02 times 0.15 and add that to the other 0.98 times 0.998. A little sloppy, but you get the gist. 0.02 times 0.15 plus 0.98 plus 0.998.
It's 1.981.
Beautiful. 1.981. Something about that seems right. Oh, I'm stupid. Sorry. Hold up. Let me do that again. I didn't multiply. 0.02 times 0.15 plus 0.98 times 0.998.
It's approximately 0.981.
Beautiful. which is 98.1%. So we're looking for something like that. 98.1 shows up in option A, and we are done. All right, I'll get a glimpse at all the work we did today on this problem. And I'll go ahead and show you that very first one we did in the other video. All right, if you have any questions, please let me know.